Hello, my name is Won-jae Shim, and I teach Earth Science at Wonju Girls High School. I would like to present the case of applying a parallel Earth to Korean teachers and students and a case applying Python to astronomy education. First, I will present the use of the parallel Earth program in an Earth Science class. The Parallel Earth program is an astronomy education program developed by LOSA of NASA. Seasonal changes and the principle of day and night occurrence are natural phenomena that can be easily understood when looking at the Earth from the space. However, it is very difficult to understand these natural phenomena within the Earth. The Parallel Earth program has the effect of looking down at the Earth from a spaceship in the space. Therefore, it is easy to see the causes of seasonal changes, day and night, and different direction of shadows for each region at a glance. LOSA conducted a training program on various hands-on astronomical education programs, including the Parallel Earth program for Korean science teachers in 2020. I participated in the development of YouTube videos and educational materials that introduce Parallel Earth program to Korea. This activity was organized by the Korean National University of Education and Korea Astronomy and Space Science Institute. The program was also introduced to astronomical observation training for teachers and experimental training for middle school science teachers. The Parallel Earth program was well received not only by elementary school teachers, but also by middle and high school science teachers. Also, at the IAU General Assembly held in Busan this year, a training was conducted for teachers working in Busan. The Parallel Earth program has also been applied to real science classes. Parallel Earth classes were performed with various school students. The students were very interested in the fact that the direction of shadows was different for each region, that they could easily understand the principles of the appearance of white nights and polar nights, and that they could easily understand the principles of the appearance of day and night. I'll continue to teach parallel Earth classes with students in various ways. This is because I am confident that the program is very effective in improving students' abilities to think astronomically and scientifically. Next, I'll introduce about to you astronomy classes using Python. Using Python, a class on the data analysis process was conducted, which is generally difficult for the students to experience. A special classes using Python was held on one session. Special classes using Python were conducted at various schools. During the classes, it was taught that the data analysis method observed by the Herschel Space Telescope and the RGB color analysis method of continuous spectra were taught. Python classes were also conducted in regular classes and for student club activities. These classes lasted for a year. During this period, we performed various activities such as Hubble data analysis method, Kepler third law, planetary orbital drawing, Voyager spacecraft's current location and solar scale, distribution of globular cluster in our galaxy, and analysis of the Andromeda galaxy, Centaurus A galaxy, IC434, and Barnard Nebula data, and RGB color analysis of continuous spectra. These four features are the resulting parts of the student's direct Python analysis. After these classes, students were able to implement scientific logic courses on their own. The classes developed students' scientific and mathematical thinking skills and their ability to utilize computers. Finally, they can indirectly experience the scientist's research process in field. That's all the presentation. Thank you for your attention.